So complete combustion. So carbon plus oxygen yields carbon dioxide. That one's done. And if we take a look, we could sit there and say, okay, boom plus boom. Each of these are 0 because they are at the state. So we take products minus reactants. So it would be, oh, we don't have that up here. All right, so we're good. If we take H2 plus O2 yields H2O. We do need to balance this. For every 2 moles of H2O, we require 2 moles of H2. And then we need to do C2H5OH. Plus O2 yields H2O plus carbon dioxide. Oh, these are the enthalpy of combustions. Okay, cool. So those are actually, that is the enthalpy of combustion, which means when 1 mole of carbon reacts with oxygen, that does give us delta H as equaling negative 393.5 kilojoules for every 1 mole of that carbon. For H2, delta H of combustion is negative 285.8 kilojoules per mole. And we need to balance this a little bit. Here we have 2 C's. So we need a 2 there. 5 plus 1 is 6 H's. So we need a 3 there. 3 plus 4 is 7. 7 minus 1 is 6. So we need a 3 here. Again, this is the enthalpy of combustion. So that is kilojoules per mole of C2H5OH. So the delta H there is negative 1366.7. So that does give us each of those different delta H's. The problem here is that this is the H2 for 1 mole. And how many moles of H2 do I have here? Is Hayden out there?
2.
2, good. So what do I need to do this? Negative 285.8 times 2.
That would be negative 571.6.
So the fact that this is kilojoules per mole, we have 2 moles of H2. Whenever I balance this, I put a 2 there. But keep in mind, this is referring to the number of moles for the substance. Here we have 1 mole of C2H5OH, 1 mole of C2H5OH, 1 mole of C, 1 mole of C. So that's the reason why we multiply this one by 2, is that this is 1 mole of H2, but we actually have 2 moles whenever we balance it. Questions there? All right, so write a separate balanced equation. I believe we've done that. It says, B, in principle, ethanol can be prepared by the following reaction. In principle, 2C plus 2H2 plus H2O yields C2H5OH. So if it can be made by this equation, well, we can take these 3 equations. Here we have C, here we have H2, here we have a combination of H2O, and here we have the product C2H5OH. We can take these 3 equations and using Hess's law, make this equation, which will then give us, if these are the individuals for all of this, and once we fix it, we can add those together, and that will give us delta H for the whole reaction, the new reaction, I should say. So, first thing is, I see I have 2 carbons here. I only have 1 here. So I need to multiply the top one by 2. Two times negative 393.5.
It's negative 767.
Do my math there. Up. 2 times negative 393.5.
It's negative 787.
There we go. That is negative. Since we did not reverse the reaction, we don't change the sign. The 2H2, well, I have 2H2 here, plus O2 yields 2H2O. Not necessarily happy about that because of the H2O there. It's on the reactant side here, it's on the product side here. But we didn't change anything for that. We used everything the same. If we need to change it, we'll change it in a bit. The big one here, we need to change and reverse this so that it yields C2H5OH. That means we're going to, instead of having negative, we're going to have 1366.7. We need to react this with 3O2. And we need to have our 3H2 here and our 2CO2 there. Now, I feel good about these numbers, but I do this last check to make sure that everything is in working order. So 2CO2, 2CO2, 2H2O, 3H2O gives us 1 H2O left over. The C2 H5OH is good. 3O2. Well, here we have 2O2 and 1O2. So that's going to be 3O2. That gives us 2 carbon, 2 hydrogen, plus 1 water, yields ethanol. So now we just need to summation these guys. Negative 787 plus negative 571.6 plus 1366.27.
It's 7.67.
Messed it up a little bit. .67. I believe it's let's do it one more time. 787 plus 571 minus 1366.7.
The answer is negative 8.7.
Yep, there we go. So it's 8.7. And I believe it is negative. Yep. Yeah. Basically, I just switched the signs in my head. You want me to do it regular? Negative 787 minus 571.6 plus 13.66. Ah, geez. It is the actual calculator. Too early in the morning for that.
So if it were to ask like per mole for that equation, you divide it by 2.
Give me 1 second. Geez, I can't even not type it in my head. That says 13.66, but it's 1366.7. What's going on here with me? Is it 8.1 positive? Yeah. All right, cool. Probably better just to use a calculator than to do anything in my head this early. 8.1 kilojoules. That is the delta H of this. And the question was if we're talking about, since we're talking about 1 mole of this C2H5OH, that is the amount of energy it requires to make 1 mole of this. If you were dealing with the carbon here, then yes, you would divide this by 2 because this is kilojoules per mole of everything in there. And there are 2 moles of just carbon. Whenever you're dealing with this, if we were to switch this around, it makes sense that this is positive because we are creating ethanol. If we were to burn ethanol, if we were to switch this around, then this would instead become negative, right? If we were to, somehow have ethanol decompose, it would be negative. That would be 1 mole for the ethanol decomposing. But if we were to look at this with the carbon, this is per mole. So whenever you look at this, this is 2 moles of carbon. Was that Hayden that asked that question?
No, it was Dylan.
Okay, Dylan, does that make sense? So 8.1
Yeah.
kilojoules per mole. But when we're looking at this equation, it's 2 moles of this. So that would mean it would be 4.05 kilojoules for 1 mole of this carbon. I think you probably can do heat of formation with this with the ones they're given. Hess's law, I mean, you could take products minus reactants, but Hess's law works nicely for this. Last but not least, yesterday we talked about standard entropy. We talked about it very quickly, and we're going to talk about it very quickly again, just because I want to give you an idea of what it is, but not necessarily care too much about it. Just because we're looking at that. That's like in the last unit. So the universe tends to go toward disorder, and entropy is disorder. So we talked about if you have a junk drawer or something like that, I mean, it just becomes junkier until one day when somebody decides to put energy into it in order to make it less junky. That's the thing. That's why the universe tends to go toward disorder. If we take a look, if we have liquid H2O that goes to gaseous H2O, this is less ordered. These particles have some interactions through what we've talked about as hydrogen bonding, stuff like that. These particles are moving faster. 1, the distance between them is much greater than the size of them themselves. 2, and they're moving in every which direction. And if we look at them as an ideal gas or whatnot, we have them as not having any interactions with each other. Solid would even be more ordered than liquid. So that's one way to look at entropy. Let's take all right. Let's just take, moles of a gas. Let's say we have 1 moles of a gas plus 2 moles of a gas yield 5 moles of a gas. This also is more disorder because we have 3 moles of gases over here, and here we have 5 moles of gases. More gaseous particles here would mean that there's a lot more disorder. Basically, we're just increasing entropy, or what we call disorder. The cool thing about just finding the standard entropy of change is that it's the same thing as before. Delta S equals the summation of S of the products minus the summation of the S of the reactants. So if we take a look for calculate for the reaction given in part B, so this is our products. We have 1 mole of that, and remember this is a molar value. So we have 1 mole of ethanol. So our entropy for that is 160.7. We have 2 moles of the carbon. So we have 2 times 5.740.
The answer is 11.48.
And then we're going to add to that the H2, 2 times 130.6.
It's 261.2.
And H2O. 69.91. 11.48 plus 261.2 plus 69.91.
It's 342.59.
160.7 minus 342.59.
That would be negative 181.89.
181.89. So if we take a look at this, the entropy has gone down. Looking at this equation, can anybody tell me why? Why we've had a decrease in disorder?
Because it goes from like separate kind of elements and compounds into one little like thing. I don't know, like a dense compound kind
Yeah.
of. So like the order would be like it'd be more ordered.
You got it. We've got 2 moles of gas here, and then we've gone to liquid, 1 mole of liquid here. Another thing is we have 5 moles together going to, this ordered C2H5OH compound. For sure. Good job. And again, if you don't understand entropy, don't worry about it for this test this week. We will talk about entropy more near the end. Our next topic next week deals with equilibrium, which I'm interested in seeing where we are with this, because this is actually the first unit that we reached in lockdown if you were in X chemistry last year. Basically, it's the one where we take the products divided by the reactants defined for the value of a constant. And we take each of those products and reactants to the power of their balanced equation coefficient. But it'll be interesting. This is the one where I'm thinking like maybe this is where we reach a slowdown. We are finishing up unit 6 to complete everything before the AP exam. We have 7, 8, and 9 to complete. Because we're kind of not able to do labs, that's going to save us a little bit of time. But keep in mind, since we are in this hobbled schedule of 2 days here, 2 days off, and Monday asynchronous, I still think that we're going to be well okay when it comes to time and the timeline. I know that if you guys, does it even show you guys this on the AP test, AP classroom, where it's like, here's the schedule if you've only completed 25% of the material. It does show me that, and like I'd hate to think that there are some classes out there that have only completed 25% of the material, but I mean, if you took X chemistry, you've already gotten more than 25% of the material. It's just remembering it and stuff like that. Questions before I get off here? I will try to get the answer for number 26 up. I will put this work up, and I'll post those hopefully before the end of the day. And if I don't have the answers in here, I will try to at least get the answers in. But I'm not gonna say that I'm gonna have time to complete this entire packet before the day's out. With the CP class is doing a laboratory today and X chemistry reviewing for tests, so that's gonna eat into my time. If you have questions, by all means, stick around. If not, have a great weekend, and